Okay, so let's continue. This morning we fixed a couple bugs that were basically causing this to be not usable. Um, so now it is usable, but there's still more bugs that basically are going to make it crash if we run this for too long. So I'm just going to make this giant for now. Well, actually, this line length thing is not the problem, but we're just going to make the backlog 64 megs. So it's going to store 64 million characters until I just fix the other bug. Well, you could make it this big and it would still be fine in normal operation, but let's do this, rebuild. We need to rerun it. Now, let us go and fix this other bug. So let's actually just cat the old notes here. So this first thing we need to cover right now is this ring buffer mapping. I don't even know why it was working before. Sorry, it wasn't working before. I think I had something that was working and then I changed it at some point and to thinking it was still working when it was not. And so now it's broken. So we will fix that first. Ring buffer. Basically, the issue here is that we should be initializing. So when we allocate this, we use like an anonymous file descriptor. It doesn't need to be a real one. We're just trying to get some memory to store the mapping in. But then down here, we actually need to have a file to like actually link up these other three mappings to this original buffer. Now, the way to do that, well, there's two ways. On Linux, there's a syscall called memfdcreate. I'm not going to use that because it's not portable between different like Unix, Unix versions. But what is portable is SHM open, and we're not even gonna like we don't care about the memory, the name of this stuff. Let's just open this. Or any of these flags really. So we're gonna do this. We're gonna do I32FE equals SHM open. The name we're gonna use is I don't know VTGL RB. I don't even think like this name matters. We're just gonna do this though. The O flag, again, I don't think this matters. But we will do this. So actually I don't have pasting yet, so we're gonna have to just type this properly. That's okay. Just want people to be able to read this. So ocreate, if the shared memory exists, this flag has no effect, except as node is under oexec. So we'll just specify both of these. Even though it won't exist, so it won't matter. But just, you know, just in case it decides to complain. And then for the flags here, or the mode, I guess, I don't think like the mode really matters either. Pretty sure the mode can just be 0. Well, we'll just specify 0600, which just means it's open for read write by the owner only. Then So if fd equals -1, ring buffer failed to open shared mem. Let's call it memfd, even though it's not that. Let's say we're putting n in here. Okay, so then if that was successful, we're going to truncate it. F truncate fd, I believe, man, f truncate should be the length, so just the size, not the size, the capacity. This part's fine. Then in here, what we actually want to do is just map the same fd over and over again. We can also do a shm unlink immediately. Oops. This doesn't matter because we're just unlinking it, so this doesn't even matter if the name is already existing or not. We're just gonna do that, and then we're gonna fix this. Okay, and then after this, all we can do, after we're done doing this, we can just close the file descriptor. It's already been mapped. So if we do this, then we reload. So now presumably everything is working fine. I could just go and yeah, let's do it from the debugger. We actually don't care where this breaks. We just want it to break somewhere. As long as we're in here and we've got access to the term, which we do, you can get the address of that log buffer. So we're gonna do uint pointer t term.log.buff in hex. Copy that. I'm gonna go here. This is visible on the stream. So we're gonna go to this memory. So you can see it's got this escape bracket 1 m vtgl blah blah blah. And we're gonna go to uint pointer t term.log.buff plus term.log.app. Oops, I don't know what I did there. We're gonna do that, and we're gonna go to the next, the ring buffer, next page, and it should be, it's not the same. That's weird. I mean, that's correct. Huh. So let's see here. Why would that not work? Shouldn't be any offset in the file descriptor. Um, the size of this mapping should be exactly correct. Do we need to keep this open? I'm not sure. So this is going to be leaky. If we need to keep it, I'll just leave a note there. Can do that actually instead. Let's go back into here and we're gonna run. And then we're gonna just break somewhere. This is not where we're broken. I'm just gonna break here in a reasonable state. So go to memory. So this is the normal buff address, right? So you got that. And then if we go to this other one, it's not showing up in that page. That's a problem. Let's also check back one page. So it's not there either. So that's a bit of an issue. Let me think here. So what are we doing here? So we have map anonymous, map fixed, map private. None of this should matter because, well, we don't really need map. Maybe a map anonymous. Oh, that's definitely wrong. That shouldn't even. Surprised that even works. Can't use that there because it's not anonymous anymore. Oops. Okay, so we have this thing mapped now, and presumably we went one time through the loop, but we'll just see. We'll grab this base buffer. So there it is. That's still not showing up in the where it's supposed to show up. We do need the fixed, and the private shouldn't matter. Let me just. So we could try the memfd create. And if that one works, then that's going to be an issue, but let me just check here quickly. Unless the mode's just wrong, but I feel like the mode... Okay, so we got some stuff there. Go to our address, we've got some stuff. Go to this other address. It's nothing. That's really weird. Let's try then using the memfd create. We're gonna try memfd create. I'm pretty sure I had something working though before, so this is like a little weird. Call this mfd name. And then I think we need to we have to define GNU source for this one. And then we can go ahead and take memfd create. Oh yeah, and then don't need any flags for this. We're not going to do that. I'm going to truncate it. It shouldn't be on. I'm pretty sure we can still just close it after this, but okay, so said the same address somehow. I don't know how, but it is. Yeah, that's really weird. I don't know what the problem is. So yeah, I know we're just leaking that file descriptor. So we got this correctly. This capacity is all good. Oops. Cert. It's like, unless I'm doing like something really weird here with this building that's causing it to not work, but that wouldn't really make sense. There's our data. There's our data. What happened? There's no data at the first one. So, okay, let's just verify this. So it's there. It's not there. Wait, what? Yeah, no, it's not there. It's not there. Okay, that's not correct. Because that page should be getting mapped to the same underlying operating system page. And if it's not, there's a bug. So let's just try this to share, even though I don't think it's supposed to be shared. I don't think it needs to be shared, but okay, so we got to someplace. We're gonna get this. It's gonna have some junk in it. Okay, I think it needs to be shared. Yeah, there we go. Weird. I don't know why that needs to be shared, to be honest. Does mmap tell us? Mmap shared describes the disposition of write references to the memory object. If mmap shared is specified, write references shall change the underlying object, which is the file descriptor. Okay, so let's try to close the file descriptor then and see if this still works. Looks like it still works, so there's the normal one. Here's the one at +1. So you don't need the file descriptor to stay open, but you do need to actually map it shared for some reason. So that's fine. Let's try to do this the SHM way again. Because that one is portable. Do that. Do this. Oops, that needs to be MFD name. We don't need to define the new source anymore. Still run. Continue. So the base one, there the thing is. The second one, there it is. And the first one, there it is. So that's fine. So I don't know why that was working properly before. I mean, sorry, it wasn't working properly before. I don't know why that needs to be. I don't know why I thought that didn't need to be shared. Okay, so this name doesn't matter. We can close this. Go to that line. Close the file descriptor. So that fixes that bug. Right. So that we don't want to commit. We're going to delete this part. The rest of this is correct. Actually map the same page in the input ring buffer. We were doing that wrong before. Definitely don't know what I was typing. Okay, so got that going. Now, we're gonna write a test for that one because that is something that should not be wrong. We're gonna add this. We're gonna finish this test in a second. Wait, let me check here. Let's not. We'll write this test first. It's okay. And then we'll write the other test. Let's do that. Okay, so we're gonna change that in the middle of the long line. So here we are changing the cursor state in the middle of the line. And then here we're going to place a non-ASCII character on the line edge, on the long line edge. And then we're going to do that. So we're going to do long line data, split long. We're going to actually make it a long one. It's not going to be that exact character. And the reason why is just because this will make sure that we're not doing something stupid that just works with 2 lines. Let me just believe I have some code somewhere for testing this. Yeah, okay, so we're gonna make a long character here. I believe this is just the Red Dragon Mahjong tile. UTF-8 encode. Right, they're not pasting. Why do I keep trying to paste? We should add that. That's not that hard to add. Is that what it's called as well? I don't know. Forgot. Yeah, it's called UTF-8 encode. And that one should just be 4 bytes long, if I'm not mistaken. Now, I might end up putting this in here backwards if I'm not careful. And it's not going to be valid, so if that's the case, then I've messed up. Let's make sure I'm printing the character. Long line dot data. Split long dot split long plus 3 equals 0 space long line dot data. Pass this to a char pointer. Plus split long minus 1. This is going to be backwards if I'm not careful. let's just, how was I doing this test before? I think we just build the test, we just don't run it. So let's just try to run it. There's the encoded character. This font clearly doesn't have color emojis or whatever. But it's, yeah, it's clearly the red dragon mahjong tile. We have to set that properly. That's okay. So how was I doing this before? Yeah, so we were doing like this check status thing. Like check cells equal, right, so zero is just failure. So that's okay. So we got a character there. So then what we want to do is grab from somewhere here some code. So we want to grab this code. I don't think we want the blit lines. We just want to simulate and grab the cursor, but we're going to have a parsed lines. We're going to give that the long line. Then we're going to go ahead and we're going to say, so first of all, we're going to assert, we're not going to assert. The result dot status, I think so, right? Yeah. Parsed lines should equal 2. Yeah, there should be two parsed lines. So that's the first part. And then so we don't need to split lines. Let's just start with that, make sure that compiles and works as we're intending. Why do I have like a assert in the test? Wait, how big? The ring buffer is how big? That's the full size. Let's run the test in here, I guess. What did I break, huh? I don't even know how that would have broken it. There's our raw string. Where are we here? Sorry, we're not in the right function here. What's our line? Wait, what? How did that even happen? Why is that like... How did we get garbage here? I think I need to like remember to do something here, which is like... I think what I'm not doing is like resetting the... I think we need to do something here about resetting the terminal state after this. So between each test, we're just going to... I see. Um, Buffer reset. We're going to add this as a helper function here. Fix that, figure out what that flashing is, but so this is interesting. We can save those. That's going to tell us some info in a second here. But let's go back to this for now anyways. So here what we want to do is say T to ring T to, what's it called? I don't even remember how these are called in here. T to log dot write IDEX equals 0. T to log dot build equals 0. T to log lines dot build equals 0. T to log lines dot write IDEX should equal 0. Let's just go here and see if that would fix the problem here. So we go to this when we're calling cursor movement and we look at the terminal. We got log is filled 46 cap write IDEX blah blah blah. And log lines is filled as well. So we're just going to reset that between those. Okay, there we go. Make sure we got a nice clean buffer. well, we're just going to overwrite stuff, but that's okay. So now, cursor at boundary. Okay, so this is the first part. We need to make sure it's split. So that part's successful. Now for the next part, we need to so we have two steps here. We have to simulate line. And we need to check that the we need to check that the so there's two things. So this or T2 line, T2 log lines, buff 0. Line length. So, or not that, should be greater than split long. After the red dragon. Um, and then we want to do the other one. So check the cursor cursor state was transferred. Okay, so we're gonna do that. I need to pass F7 through to the terminal. So what we want to do here is do we're just going to use mem compare. Okay, so we don't have a function for that. It's in string. I think we can just use this. It returns greater than, equal to, or less than 0 if the object pointed to by s is greater than, equal to. So if it's equal to, it'll return 0. So we need to just do not memcomp. log this is term here. Term to log lines dot buff dot what's it called? Cursor state. Term to log lines dot buff one dot cursor state. Size of I'm gonna look at that. I do want to look at that bug. I'm probably gonna step through this and just make sure this is doing what I'm wanting it to do. I need to actually call this the right thing. And I need to I could obviously just write that myself, but we have no use for that, I don't think, in the terminal. So until we have use for that, that's gonna just be in the test only. These need to be pointers. Okay, there we go. So that's fine and dandy. Now let's go over here. And we're going to set a breakpoint in this function, wherever it happens, and run it. So we are here, step, step, code that, shove that in there. Parse lines is 2. Step. Oops, I wanted to step. I should have stepped into that, but anyways, we can just check that. Wait a minute. That's not right. Yeah, that's not right. Hello? Where are we? Wait, what's... Let's try this again. I don't know why that is broken. I don't care about that. Step. Why is that, like, wrong? It's, like, way too long. It doesn't even make sense. What happened there? Okay, there's a mistake again. In the tests, which is that the ring buffer I think we need to actually just make sure we call copy into ring buffer. Even though I thought this would have worked anyways, but let's just copy into ring buffer term long line. This is going to return a size. What are we even doing with that size? I see. Okay, let's just use the launder static string function then. Which will give us the raw. This isn't actually a static string, but that's okay. What's it called? Yeah. We're going SA raw equals this. And in this reset buffer, we're gonna do that as well. Yeah, this is not what we need to do. Let's pass the term in. Okay, so now we have some tests that may or may not work properly. So that is going to be fine. Raw as the length of the full thing. Parse lines equals 1. That's wrong. Why is parse lines equal to 1? This should be and as well. Let's make sure this is just correct. Okay, let's continue in here and see what's going on. Count here is less than that. Let us put a, where should we put the break here? Put a break here, that's fine. So we still have some stuff to process because this is going to be the this is going to be where we set the cursor. So that's fine. Let's just make sure this all looks good. So we did not do that yet. That's good. Raw.len, we still have like a bunch of it left. So then we're just gonna continue. So now we've got 133. Why do we got 133 left? I guess we need it. I guess. So what's data? Oh, yeah, this is the UTF-8 stuff. Right, yeah, that makes sense. So this is correct. We go here. That didn't split. We didn't increase our parse lines. We got this, which is correct. There should be... Yeah, so this has the rest of that character in it, if I'm not mistaken. We do this, and we go to memory view. 9F8084. No, we're missing the first byte. I guess that doesn't matter. Let's just see what happens here. This is kind of inefficient if there's Unicode, but I have to think about that. So we need to make sure it doesn't do this the whole time. It should have to go through the Unicode one by one. Now we've consumed that. We should have... Okay, we still have that. So we're going to consume that. Now the rest of this is not... I see what the problem is. We go into here. That part's fine. So here is where the problem is. So this line length is now longer than that, which is what we want, right? But we do not want... We want to split the line here, even though the last char... Even though last char and 0x80 is still set. Be right back. Okay, so here's what I'm thinking. I am thinking that first of all, this is probably actually fine, but what should happen instead though is we should just fix this so that we skip over so this UTF-8 mask. Easy count needs probe. This looks wrong. So I think that let me step through this again. Let's disable this for now. Okay, and then we can re-enable this. But let's just go here. I want to step back into that. So I want to see when we're in here, what happens. So here, this isn't the one I'm interested in yet. So this one is the escape code. So we're just going to continue. So this is the one I care about. So we go in memory to this address. Oh, sorry. Data. We want to go to data's address. Wrong address. Okay, so if we go to data's address, which is F4, that's here. So what are we going to calculate here? We're going to calculate 11 bytes, which means there's 5 on this overhang. I need to look at those, why does this not give you the SSE registers? Okay, I really need to go and work on this GF2 because I need the vector registers. This is rough. I think you can put like X and M0. Yeah. Yeah, you cannot put a watch for registers, so yeah. So that's annoying. Okay. Because what I want here is I actually want this to go over. So if we actually advance data by 11 bytes, where does that put us? If we just cast this to a uint pointer, so that's going to actually give us that exact byte that we want. Yeah, so that's going to place us right on the start of the byte. Um, so that's actually fine. So I'm going to do this, going to skip over this. So now data is sitting right where it should be. No, it's sitting one pass because we consume. Oh, I see what happened. So this get ASCII, we just skipped over that one byte. Okay, so that shouldn't be like that. That should be um split raw input to lines. This, I don't think this is right. I think this needs to be peak. Specifically peak raw 0. Now, is that just gonna fix the issue? It might. Not sure. No, I just did there, but that's fine. It looks like I broke something. We're just looping now. So that's actually not fixing the issue. That's worse. Let's just go through this logic again. So we do not want to skip over that first character. We want to compute the length of that. We don't want to do that here though. What's gonna happen is we're gonna go in here. We're gonna see needs proc. Advance is gonna be 0. We're gonna skip over 16 of these. That's gonna give us a bunch of zeros. Oops. That's gonna give us a bunch of zeros. So then when we do has Unicode, this is gonna be cleared, which is wrong. If we break, we have has UTF-8, that's gonna be correct. But we didn't actually advance the data at all. Okay, so we need to do something else in here that I'm not doing correctly. So what can we do here? I need advanced to go, I need to basically calculate how much of that junk. Okay, so let me see. So we land on a Unicode character, which means that we find that the advance is 0. I feel like this mask is like not quite right. Yeah, so let me think about this for a second. But first of all, I feel like we're like doing something dumb here. Like this. Possibly here, this just feels like it's gonna be slow. We'll have to measure this after. Um, You see here, what was this? Like get UTF-8. This gives us a U32. It consumes everything. But I'd like to know how long it was, not well, I guess we don't need to know how long it was. We just need to do this. This is probably slow. We don't actually care. We just want to read it. Um, if get UTF-8, what's our thing here? Raw. Less equal to U32 minus 1. Then we need more bytes. And the only way that happens is if this length isn't the right, if there's enough space available. Um, old len equals raw dot len. That would be correct here. So this should at least not just do a dumb. No, it's still doing the dumb. Oh, we don't need this actually anymore. I think that's completely unnecessary. Because, yeah, so this will overwrite whatever that was, so this will consume it for us. I mean, that's a little weird that that was still breaking like that, but okay, so that's still wrong. What is going on here? Why is that wrong? We can actually probably test that in this test program though. Okay, let's take a look at what is going on here. um, advance was just 0 for some reason. It's an escape. So we did that. Raw.data should now be something else, no? Why did it not like get rid of the escape? What happened? Hold on, what? I'm confused. Why is raw.data not advanced? So old raw, consume, default is break. So why is like raw not getting consumed? Or it is. No, it is. So why is this just looping? Ah, I see. We still just need to consume. That's a problem. We always need to consume one. Consume at least one. Okay, so we're back to working state now. um, so how's the test? This one failed, but why did it fail is the more interesting thing to check. So let's disable, run. Okay, we got this. Step through, did that. Step into here. We're gonna re-enable these. So this one, let's take a look here. Advance is 0. We're at the escape. So we can just continue. Continue, doesn't matter. Okay, so now we are at the, okay. We're at the one that contains that, so we're gonna do this. We're gonna get 11. We're gonna skip over it. We're gonna do this. So we've consumed right up until that point where that starts. Raw.len is fine. We're gonna go in here. We're gonna grab this. We're gonna do this. We're gonna find that it has Unicode. We're gonna get the old len. We're gonna get Unicode, which is gonna make the raw length shorter. We're gonna go over that. End equals that. So now the line length is 4099. So we should be stepping into this parse lines. That's right. We feed a new line. And then we're back to this. So if we go up here, this count is the rest. And the rest of it's just 0. So if we continue, we'll get to here. Remove this mask. Consume. Why is there still 13 characters? What? That makes no sense. There shouldn't be 13 characters left. So our line length is now 4081, which is less than this. So we're not going to split a new line. Nope, we're going to skip over. Oh, right, we have to skip through this one at a time until we get to the... Yeah, it's annoying. Okay, so that's good. We've processed how many lines? 1. We've parsed 1 line. Shouldn't this be parsed lines? Oh, because there's 1 remaining that we didn't split yet. Right. Okay, that's actually correct. We should just shove a new line at the end of the buffer to make sure it just splits that line. Yeah, we're gonna shove a new line at the end of that buffer. This part is probably wrong then. Wait, this is gonna pass though. Why didn't that work? Let's bring this over so it's visible on the stream. So we have here, fine. Yeah, right. So, oh, right. Sorry. This isn't the starting state. This was supposed to be the simulate line to get the end state. Okay. So, tests are difficult. Mostly when you're fixing bugs in the middle of writing tests. Okay, so this, we're gonna shove a thing at the end of the line somewhere. long line dot data 8192 minus 1. This should be long line dot len minus 1 equals slash n. That's good. Then this will come out as true, presumably. Let's just do this like this. We're going to split this up just so it's a bit easier to read. Oops. We're going to do that. Simulate cursor term. So how did I write this again? That's in the debug code. Simulate line, my bad. Line n dot state, cursor line 1 dot state, which is the starting state. Oops, missed a thingy. Missed another thingy. Okay, so now we can run tests and it should be fine. We'll just step through to make sure this is doing what I'm expecting it to do. So we're gonna put that breakpoint and we're gonna disable these other ones. Delete those ones. So we parse 2 lines, that's true. This is also true. This is going to give us a line end, which I don't really care about the rest of the dealio there, but we can look at. Let's get rid of all this. So line end, cursor ended in a state. Okay, there. So this is what we actually wanted. So this should now be a success. Cool. So done. Didn't actually work. Okay, so let us do that. I think this, I'm still pretty sure this thing can't happen if the ring buffer is working properly. So I'm gonna leave that commented for now. I'm gonna add the test.c and we're gonna add the terminal.c. And we're gonna do this. So we're gonna say um, properly insert full UTF a is added to line end and add test for this case. I don't know. And add this test case. Okay, so we got that test. Now what we'll do is we'll go and add the ring buffer test that we were supposed to have. So oh. Oh, okay, so I don't know what that's about. Um, so it's add working ring buffer. So to do this, we're just gonna basically shove the thing at the start of the ring buffer. um, fee. Um, result dot status equals um, buff 0 equals term term dot log dot cap and term dot log dot buff 0 equals term dot, this is gonna look really jank for people who don't know what's going on here, but um, but it is 100% correct. So right, my bad. Mostly actually not my bad, mostly C's bad. Okay. Oops. Okay, so we got that. Now we can run this, and that one's just gonna work because the ring buffer works. Um, the ring buffer didn't work, that would no longer work. Like I added an extra line for some reason. I don't know why I did that. Okay. Had a test for working ring buffer. Check if ring buffer works. All right, so let me take a little break here to get another tea. Oops. Well, okay, so I'm gonna pause that for now. We're gonna leave this without the file name expected. We're just gonna leave this open. Um, and I will be right back. Okay, so tea is brewing. I'll grab that in a second. One thing I should test is actually if um we fixed that line buffer issue, which I think I did by fixing the ring buffer, but possibly the line buffer thing is still not correct. And then in that case, it needs to be fixed. We're gonna go into util.c, util.h actually. So here, backlog lines, we're gonna change this to 1 megabyte, and we're gonna change this back to 1024 UL. We build that, we're gonna close this, reopen it. And we're just gonna scroll up and down to get this to just fill the buffer. Okay, so it looks like we didn't fix that issue. Scroll until we hit the issue. So yeah, we did not fix that. Let's see what's wrong here. Stack, push line. So this is happened here. This is L. L yeah, L to end is before L to start. Yeah, so actually that thing we had, that test I think I had that I commented out is probably actually correct. This is not what it's called. It's called LB to buff. That would be correct, it looks like. Let's try to hit that again. Wait, I definitely hit it. There's a couple things I need to check here though. I need to check that term p2 log should be filled. So it is. Then we need to check the okay, so that makes sense. Here we have so we have 361. And 361 is this line that we got here. Just go grab the T. So let's just check that L to end is actually in the bounds. The step up one. Here we'll have to do this. I'll have to do line. Let's do this. So t to log dot buff plus t to log dot cap. Actually plus twice the capacity, so that's the end address. So EE2, so 7FF EE2 is less than the end of that, so that means it's in the boundary. But for some reason, the start ended up further than that. So does that make sense actually? So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. E. Oh, the start's outside of the bounds. Why is the start outside? Oh no, sorry, the start's not outside the boundary. Sorry. I should get rid of that for now. Just really make sure we actually hit that before I go and mess around too much with this. If we didn't hit that, then I don't want to be messing around. Okay, we did. So it's like if we added capacity to the end, it would be in bound. It would be fine, and it would still be in bounds. So I'm not sure why this. The problem though is that like this shouldn't be. This should only happen if there was unprocessed bytes. Maybe not. See if we can still hit it. I mean, that's like some super janky thing going on though. Not super. Yeah, we hit it. So, and we hit this. It's this exact one. It's not the other one. So that means this is like somewhere else is getting screwed up. Or I typoed this. Or we are breaking early before this happens, like. But this feed could be feed lines. Before we just do this, technically it could be equal to, but we'll just leave it like this. So I think we're gonna hit that one instead. At some point. Yeah, so we hit that one instead, which is more correct. It's happening here when we do a feed line. Let's take a look here. So raw.len is quite long. Do terminal. Here, I want to see what passed raw in. 842. So we only parsed 3 characters, which means that I think it's got to be when we're doing this here. So this will do a wrap for us. So here, like, what's raw.data? And log to buff, the starting buff position, you can't see it, now you can see, is EE300. So this is before the starting position, which is fine because, let's just delete some of this. So if we go here and we do minus log to cab, so that is EE2000. So this is after that. So it's like perfectly a fine place to start. I think what the problem is that there's like a line that's already started. So we have already got an end. This end is equal to the raw.data start right now. But it started right. That makes sense actually. This is a little bit this is a little bit of a problem. So we could let the line length do this. And then this would be still parsable. As long as we, in get line, we shuffle the indices around. Or line to S8, I mean. Let's actually do that. This will adjust the starting position so that the line is so that the line looks like a linear array. So what we're going to do is we're going to do we need to know like the capacity to do that though. So this can get like a little hairy, to be honest, but if this is the case, then in here we're going to do if kind of just need the whole ring buffer. Let's start by doing this. Wait, so sorry, if this is greater than RB to buff, then we can subtract one. So that should either Maybe we're gonna even have to add like just a little utility function that does this correctly. Um, because this adjusting the indices can be a little bit sketch. I'm gonna put a bunch of asserts here because this whole thing is very sketch. Or you could fix it in feedline, but I mean maybe fixing it in feedline makes sense. I'm not sure. We'll think about that. Oops, not times. Is greater than RB to buff minus RB to cap. Okay. That's fine. So let's try to run this. Let's actually fix something here. Split raw lines. So this I feel like is not needed then if we're doing that. We're already hitting an assert here where we've screwed up some dealio. Already messed with this line, so this isn't gonna work. Oh, it's 0 now. How did this happen? Wait, how did we come in here with 0? Oh, this is the first time it goes through the loop. Why is it even... This didn't work before though. What? Am I misremembering? Like, did this actually work before? Oh yeah, it can equal. line to SA. Oops. Okay, there we go. So let's check if this is completely broken or not. Well, that is broken, the cursor movement, but that's fine. It's looking like it's correct now. Might have to check the other one to see if the ring buffer is full. Oh no, I think it's definitely full. I think it just doesn't spam the console thing there. So it definitely looks and seems correct now. That's the end of the file, which we couldn't do before. So let's get rid of this. So that definitely seems correct. Hi, is it normal if I don't understand anything? Possibly. What kind of question? You can ask any questions, I guess, and I can try to answer them. Welcome to the stream, by the way. Okay, so I believe that fixes that bug, even though this code's like really ugly. So let's just look at that code quickly from within the terminal emulator. And see what we can see about simplifying this. That's obviously a bug. I should actually dump that one. But let's look at these line dumps actually. It's gonna be not smart. um, no, so you see, like I'm writing this terminal emulator right now from within this terminal emulator. It is now at the point where it can actually be used as a terminal emulator. I would like this to not be so janky though. um, I don't want to like rat hole on that right now because I'll probably think of a better thing to do here later. So this is a good place to save that dump though, because don't know what happened there, but that's probably good to look through. Okay, so let me think here. So let's open the I should save that for now. Should also get rid of that. I don't think that's necessary. I should probably check out this utility. Just reload this. Okay, so for now we're gonna say that part is good, and we're just gonna save that. So simplify, or not simplify, correct line, correct lines when they wrap, or when the ring buffer wraps. Like, I still feel like, so that would be, because it's just a ring buffer, if the thing's the start, if the end is wrong, you should be able to find a way. There should be a way of. I guess not. No, I think that has to be how it is. When the ring buffer wraps around. Okay, so we're gonna take that one for now. Look at the notes. So we have fixed the ring buffer mapping. We finished that test that I was talking about. I think this isn't working, right? So save cursor and switch to alt screen. So here we are switching to alt screen, but we are not saving, restoring the cursor. So let us have a function here that's going to be save cursor p set actually I feel like we only need like one separate saved cursor, so this probably will just toggle that index every time. Let's write that somewhere. Maybe it should just be actually, yeah, call it cursor save. And then what we're gonna do is add something, not to this, to the term. So this term struct, we got a cursor. I'm just like a little worried that the saved cursor, that saving the position of the cursor is wrong. That could be, I might not be correct with that thinking. let's just try this. Just doing a swap here, so t to cursor, t to saved cursor equals t to cursor, t to cursor equals temp. That's the first part. Here we need to do that. So now if we do, just restart this. Oh, that was interesting. Of course, it's going to exit normally now. Oops. Well, we'll just run it from the debugger and see if we can figure out, is there breakpoints? No. Okay, good. So if that happens again, we'll see what happens. So we can go to here now and go to the to do this. Me, that looks like that's still not working how it's supposed to. Let's set a breakpoint when we swap the cursor. Um, wait. Where is that hide cursor being set here? That just seems like this part needs to be reset at some point. I don't think it's actually here where the problem is. So this should be getting reset. Probably when we do the term reset. What else is in that GL mode? Yeah, what is in that geo mode? It's in the win mode thing. We got like application cursor and we have hide cursor. I feel like that should just get set to 0 when we reset the terminal. It's just we have a working thingy there. Have to maybe just, yeah, we're gonna have to set a breakpoint there instead, because we did hit that. Um, this one as well. Why? Wait, what did we just do? Wait, that's the app cursor, not the hide cursor. Cool. Okay, so they're both set. Why that cleared them? Why are we still just going through this over and over again? Excuse me? Oh, VT, this. Like, what on earth? Okay, so we got somewhere in the end. Can I clear the app cursor? I don't know why this just dumps a bunch of garbage every time. It looks like we ended with that not set, which is weird. Still running, right? Yeah. That's weird. So then why is that not showing? Need to go into here and go to render frame buffer, which is where? Where's render frame buffer? Okay. Okay, so we got there. No, we're in hide cursor. How did we end up in hide cursor mode? Let's just step through this and see what happens here. We're just going to step through this until it returns. We know we're in that mode. You can draw that, flush that, do that, blah, blah, blah. Come through this loop. Yeah, so somehow we ended up with that set when it was supposed to be unset. Now, why on earth is that happening? Hmm. Interesting. Wait, how did we end up back in here? What? How do we end up here again? What is this L? I feel like in here we have some garbage that shouldn't be in here. What are we doing here? How many? 48 lines. Why do we have 48 lines? What is this series of garbage? U and pointer T, L dot data. But the 0M should clear the, so this shouldn't be, I feel like something here isn't quite right, but because could be because we're resizing the window. Um, Wait, what does 1049 do? 1049. I think some of this data shouldn't be getting pushed again. So wait, what does 1049 do? 1049 gets you out of the... Yeah, so this, it's actually just because that other data is alt screen data. Which means that we should, yeah. Probably time to add proper alt screen support. So the reason that's an issue is that right now we're just using one giant buffer for all the data, but that has data that's mixed together of both the alt screen and the um, normal screen. And like, so this goes to the alt screen. And it's expected to not be data, that part of the data shouldn't get replayed. So once you switch back into normal screen and you have to replay it, you shouldn't use any data from that was print to the thing during alt screen mode. Because if you do that, then you're going to replay a bunch of stuff like what we were just seeing. And all that stuff shouldn't be replayed. So let us kill this and run. So what we should do is add a second backlog. Not 8 megabytes. Like 1 or 2 megabytes is sufficient. And then what we should do is so there's going to be two. There's going to be like 2 of all of these. I think it'll be 1 frame buffer. There should be 2 logs and 2 lines. And this index should be if you're in alt mode or not. This bytes. This should be fine, I think. We don't need 2 frame buffers. Unless we... Well, okay, we'll think about that. I don't think we need 2 frame buffers. This is just getting allocated out of the memory that we have. I mean, that should be fine. Oops. So that's gonna give us that. This is annoying. This is where stuff starts getting kind of annoying. Hello, Frightful. How are you? Welcome to the stream. Um, so yeah, so everywhere we did this, we need to do um key to mode. This is a terminal emulator. Um, so what we're doing is we are editing the terminal emulator in the terminal emulator. Basically, it says the terminal emulator we programmed, and we are trying to make sure it is usable. So a terminal emulator is just like if you use like Linux, the terminal emulator is yeah, that's right. So within the terminal emulator, we're editing it. Um, the terminal emulator just displays like a bunch of stuff. So like I've got this other one open here. It just runs terminal programs. This isn't really like exclusive to Linux. Like you have a terminal emulator on Windows as well, and on Mac OS obviously. But um, well, most Windows users are not usually using the terminal emulator because the one on Windows sucks. But I'm not making like my own OS right now. I'm making my own like terminal emulator. So that's just this window that displays like terminal programs. What was I doing? So mode, terminal mode. Yeah, welcome to the stream still needs work. Yeah, everything is in C. C is the language of getting things done. This reminds me of a child. This is a child safety alphabet learning lock. It can be opened with the child safety alphabet learning lock. Well, I'm not sure like I have a better way of just describing. So the terminal emulator is like this window that displays terminal programs. So terminal programs are any program like less, like cat, like the text editor I'm using, like the shell. Yeah, so obviously once this works as a terminal emulator, you can open a text editor in it and use it to edit the source code. Yeah, that's right. What do you think about D? Um, I haven't looked into D enough to like really care about D. I'm as far as I'm aware, D is like kind of like C++, so I'm not like a fan of most of C++, so I'm probably not a fan of most of D. Okay, so this is that one. We have to do this everywhere where we do that. So actually, what would make more sense is to just store. I don't know if this makes more sense or not, to be honest. Probably there's a way of storing this so that I don't have to do this everywhere. But yeah, this one as well. I cannot really confirm or deny that. But I mean, there's object-oriented things in C that you can do as well, so it's not really like a. I think like it just says. Well, no, looking at it just straight up, like looking at what they have on their website, it looks like object-oriented to me. So, and Wikipedia also just says that it's an object-oriented language. Oh, it has garbage collection. No. No, anything with garbage collection is a big no for me. Because you can't write a program that you know the performance characteristics of if it has garbage collection. Like you don't know when the garbage collector is going to run, so you don't know when your performance is going to get tanked. Also, garbage collection is like something that programmers who don't know how to program basically use. So, like in my program, I never like, I've never have to worry about memory leaks or any of that because I know what I'm doing. Like, I don't allocate, when I allocate memory, either it's allocated for the entire life of the program or it's like a temporary thing that gets deleted on every frame. So in this program, right, I have like some memory that needs to be allocated on every frame. Like the whole push buffer that just gets used to draw this screen is like as allocated out of this like this memory, this memory variable here. Um, and on every frame, it just gets completely reset to the start for free because of how I'm using it. So if you want to know what that is, it's called like the name people use for that is an arena, like memory arena. I'm doing this wrong because I'm not paying attention to what I'm doing. Where else did I do that? Okay, so one more place in this file, I think. Okay, blit lines. I'm really gonna regret having to go through here and fix this later. um, but that is how it is. Okay, so same thing. T to log plus T to mode. Oops. And TM alt screen. That can be this. RB. Um, RB to buff plus RB to right IDEX. Okay, that I knew was gonna happen. Because I just changed the size of that struct. So once it actually built, problems happened. Terminal standards are cooked. I would probably agree with you. Most of the stuff in this is kind of a pain in the butt. What did I just do? Why did that? What happened? Wait, how did we end up here? What did I just pass in? I passed in something completely wrong. Uh, Lit lines. How are you? Low effort. Welcome to the stream. First of all, this should be this. I'm not sure what you mean by modern C. So I'm using features from C11 in CPP 26. No, this is C. This isn't C++. What's Lionel? Why would I need that? I can just program that myself. Or I can use the GPU for that, which is what they're meant for. Yeah, like that's what a GPU is meant for. Why would I use C++ to do that? Like besides all of that stuff's like really easy to program with SIMD if you actually wanted to do it, right? Like yeah, like I don't get what the point of that is. You can just write it in SIMD if you wanted to do it on the CPU, which you probably don't. Okay, so what's going on here? Wait, so what did I just do? This is all in the test. I assume GLM has esoteric optimizations. I mean, I'd rather just know what those optimizations are and implement them myself. um, but like that's not C++ anyways. That's a separate library, right? Like GLM's not C++. Um, uh, so like the only things I don't like use modern C features either. Like I only use um things that were present before C became standardized, but were removed from the standard until later versions. So like C89 doesn't have anonymous structs, which I think are incredibly useful. So this is not like valid in C89 or C99. It's only valid in C11 and above. But it used to be in like original C before it was standardized. Okay, so let me see here what's going on. I mostly just need the line buff, which I need here. LB to buff. Oops. Sad for the graybeards without STL 3D math. You mean like PDP or what do you mean PGP 10? What's PGP 10? I think you mean like PDP. Yeah. Um, I don't really use the STL libraries, but I've heard they're okay. I'm like not very trusting of most libraries. So yesterday I just like was working on my color picker that I was using Raylib to make, and I basically shaved off half the cycle counts by deleting a bunch of stupid Raylib code that was, you know, I assumed was written well, but it was not. What did we do here? Oops, that still needs the and. Okay, so next, we need the ring buff. Oops. Let's do this so it's more visible what's going on here. GC, someone was talking about DLang, and they were asking me what I thought of it, and I hadn't looked at it, but then I saw it had garbage collection, and that is basically a big no for me. I will not use a language that has garbage collection. I like to control what my program's doing. Okay, so this, we need to just copy the OS alloc ring buffer stuff from here. This is fine, we can test the alt screen later. Let's see here. So I think the rest of this looks like it should. Oops. Okay. The tests still just work. You're right. No, I'm back. I'm back. Okay, so yeah, I like I was just saying about garbage collection is like a no-go. If the language has garbage collection, I'm not using it. So like it's fun to learn how to implement it, but I still don't think it's like so like in this program, for instance, here's how we manage memory, temporary memory. There's two sets of memory, obviously. There's the memory that needs to exist the whole time, which is this stuff. Um, then there's this memory, which is the temporary memory. Um, this temporary memory gets passed around. So basically, what an arena is equals struct um, UA pointer beginning, UA pointer end. And what that means is that we pass this thing around on the stack, like I did here. So I passed it on the stack into this do terminal, and it means the do terminal can do whatever the heck it wants with the memory here. But as soon as it exits, it loses all information about what was allocated there in that temporary memory, and it basically just gets reset to what it was before you called this function. So anything that was allocated gets immediately deallocated completely for free. There's no free, there's no walking some weird stack, there's none of that garbage. Without even, putting any code in, it's just deallocated. I'm not going to do that because I don't want to commit that right now. So let's see what the problem is here. Why did we... we're not going to do that. This should be working, right? I think I just had I don't know what was going on there. I don't know how we ended up in the wrong log buff thing. Maybe I just typoed something. Well, this is going to go to the alt screen though. Yeah, so that one makes sense. We have to actually handle the place where the code switches to the alt screen. So let's handle that quickly. Split. So here, when we're just allocating these lines, we have to swap. We have to swap properly. So this set mode, all this code is fine. But what we have to do is after we call this, Vim, like keybinds, terminal emulator doesn't have like any controls like that. That's entirely like in the shell. So like if you set your shell to use Vim or Emacs mode, like VI or Emacs mode rather, it doesn't need readline to do that. It's entirely the shell. So like KSH doesn't use readline, but it has Emacs and VI support. I should say KSH doesn't need to use readline. It could use readline, but it doesn't in my case. Okay, so here, let's actually check what happens here. So if we go into here, we go into check if CSI moves cursor. If the mode just happens, this wouldn't, but this, right, yeah. So if the mode gets changed to alt screen, then we would say that the cursor has moved because the mode's changed, and the cursor got saved. So yeah, we need to check that. So check if CSI moves cursor. We're gonna save that at the start, and we're gonna do U32 term mode, theta mode. And then we're gonna do if term mode does not equal theta mode, result equals cursor moved. EMC cursor moved. And then we go and check about when we're handling this. So we also need to keep track of that here. That's kind of annoying. Yeah, exactly. Those are all ANSI escape codes. So here we need to keep track of what the old mode was as well. Now this is where it probably makes sense to not store that how I was storing it. Let me see. So we go here and we look at what we're doing here. We got a log and we got a log lines. Really what we should have probably is just logs, to, not pointers. And then wherever we define that stuff, which is where, where's line buff defined? Oh, so this is out of order. Okay, that's fine. Okay, so here we could do GLES. No, I don't think I'm using any GLES functions. I might be. So I think I'm including the header for no reason, probably, but that's because I should, well, where's the thing? This, not this one. This C file. Oh no, I'm not. I'm not even including that header. Yeah, I don't think I'm using any functions from GLES. Let me think here. So we want to you could pass the line around, but I don't really want to do that. I'm not going to do that. I'll just do the dumb thing and store the old mode and use that to check. This is the wrong way. Yeah. Okay, we're just going to delete this. We're not going to do that. We're just going to store the old mode here. Okay, so if the cursor moved, if t2 mode does not equal old mode, we have to do a bunch of junk. So let me see what got passed in here. First of all, we have to switch this line buffer out. Now we need to be careful here about the ordering of this. So this should happen first, I think. And then this new raw should be, yeah, this new raw will be advanced past the point where the cursor got moved. So that should be fine. Okay, so yeah, this is gonna be, we have to adjust this. And technically this isn't the best test. I should probably do this properly, but really that's all I care about for that. I should fix that in the other place as well. Yeah, this kind of sucks, this part. So, yeah, what should happen here is that that's usually how I do it. Yeah, I feel like so. Yeah, doing that means that you've loaded it all into memory. So most likely it's going to be a lot faster than having to deal with whatever buffered IO weirdness that you have to trust that libc is implemented correctly. In every program I've ever written where I've done that, though, I've just opened it as I've just read the whole file in first. I mean, obviously that wouldn't work if you had some giant file, but probably that's not what you're talking about. Yeah, like a few megabytes, like just makes way more sense to just read the whole file into memory. Okay, so we need to copy the remaining data into the alt screen buffer. Sorry, to the alt screen ring buffer. Well, that's assuming that PDP even has like a buffered terminal, or sorry, has a buffered standard I/O implemented on it. Um, but it might not. So you would probably have to just write the buffering yourself anyways if you wanted to run it on a PDP. Yeah, thank you. Have a good rest, I guess. Probably stop soon as well. So let me see here. Um, have to copy this into the other buffer, which is really annoying. So while we still have the old line buffer, do we need to do anything else here? I don't think so. Then we need to um, so wait, how did I there's like a commit to ring buffer or something. Read from child. Okay, we don't have that. We don't have a commit to ring buffer function. All of this would go to that function. Wait, is this even correct? We figured out the remaining is equal to RB to cap minus unprocessed bytes. Write IDEX doesn't have to start. Oh, we're doing that after we're reading. That doesn't make sense. This should be happening before we're reading. If we're gonna assert at all. It's obviously wrong, but it's obviously not necessary. Right. So here I want to move this all into a function that's like commit to ring buffer. That can go in util.c. Hey Reggie. We're doing okay, but we had to stop using the terminal emulator for a second here because um, we need to switch out how we are saving the alt screen data. It needs to get saved in a separate buffer because otherwise you just end up replaying the same data over and over again. So, okay, we're gonna do this. Commit to RB. Ring buff pointer RB size data size len. That's all of this. This goes in here. We do okay, yeah, thanks Reggie. Thanks for stopping by. And yeah, have a good rest. I'm gonna be stopping soon as well. I've been streaming like quite a while and I need to go and eat something. I probably just yeah. So here we should be checking before we just do this that there's room. Thank you, you too. Um, this also was wrong. This should have been the total bytes read is less than cap. And then we should say that here we're going to call this function. We close that. Okay, so here yeah, that's fine. So len can be like negative, so you can uncommit stuff from the ring buff. And we should just be handling that properly here. So if this goes to less than 0, we clamp it to 0, that's fine. And if it goes over the cap, shouldn't go over the cap, but if it did go over the cap, we'd clamp it to cap. That would be an error, to be honest, but anyways, okay, and then the rest of this I think looks fine, to be honest. Oops, be a comma. Yeah. Okay. So commit to RB. Split, this was like 709 or something. No, not 709. It's down here. So here we have to we need to uncommit some lines from the ring buffer. We don't have the old mode, that's okay. T to log plus old mode. The amount of bytes we're uncommitting should be the remaining bytes in the raw. So we're going to uncommit those. Then we're going to we have to copy into the new mode. So we need to do I have a function that does this, probably not. This is going to assert and then we're just gonna do this dumb thing for now. Test data I equals source data I. SIMD blah blah blah. So source is raw, dest is S8. Data equals T2 log this new mode. Buff plus the right IDEX, and then dot len will be equal to T2 log mode dot capacity. Oops, there's a typo there, but we'll fix that. Doesn't fit either way, so let's deal with it. I don't know. It almost fits, sure. Is there, no. Test, okay. Commit to RB, T to log plus mode, raw.len. Then we're going to adjust the mode to the new mode. Or sorry, we're going to adjust the line buffer to the new line buffer. And this should all be good. Not quite. Somehow we are doing something here still that's not quite right. Let's go into terminal.c and place a breakpoint when we do that stuff. Okay, so we're in here. Right now, let's delete all this. Raw equals 2200 t. What the heck? What's 2200 t? I'm not sure actually. It's old. Okay, so old contains this, which changes the mode. Okay, it doesn't matter what that is. I don't really care. So old had this. So we set the end. Yeah, okay, that's correct. So then we're gonna step into this. We're gonna step over. My pointer thing is just run this again because the whole thing is just not still broken. How annoying. The instruction pointer is not showing up properly. Okay, so here, let's see what we just passed in here. So we passed in minus that, which if we step back up one, that was the raw.len. So remaining data. Okay, so that's fine. It looks good to me. How did we end up here? Why is there like a bunch of garbage just everywhere? Why is it showing this whole string? Jesus. GDB, please. I don't know how we are here. The instruction pointer is just all screwed up. I don't know why that is. Can you do this without like screwing up the whole window? Or is this program just like too... Oh, are you kidding me, GDB? It's just like all completely... Oops. Just completely like screwed up. I'd like to see the instruction pointer, please, GDB. Like, it knows where it is. Obviously, the CPU knows where it is. Absolutely annoying. Like, what is wrong with you, GDB? I don't even know, like, what this even is. Let me kill this for a second. Let's break at do terminal. Let's break at main. Cannot find bounds of current function. Like, hello GDB, what are you doing? Okay. So if we go and set a breakpoint where we want it now, will GDB like actually work, or is it gonna like just no, it can't. GDB is like oh, GDB, why does GDB have to suck so much? It might not even be GDB, it actually might be this GF2. Maybe it's because I did this. Let's just close this. Set a breakpoint here. Continue. Nope, I think the instruction pointer is still completely screwed up. Oh my lord. GDB. So we are not going to be watching this window, we're going to be watching this window. So we are actually in here, this LB. So oh no, sorry, we're here. We're assigning this dest. Just look at dest in the watch window. So dest hasn't been assigned yet. Oh yeah, that's correct. We're gonna step into there. No, that's not where the instruction pointer is. Thank you, stupid program. Okay, so we are somewhere in here right now. We can look at dest and source. So source is this, it's less than that. This is all correct. So we're just gonna return. So we did the mem copy. We're gonna step into the next function. At least here we can use this window. Build and write at x with 0, and then we're just going to increase it because we just copied in that much data. No problem there. We're completely lost again because GDB's, or whatever this program is just awful. So LB before had, that was the old one, I thought. Oh no, they both have this. Never mind. Yeah, so the new one has nothing filled. We should not feed a line. But we should. No, it doesn't matter. The starting index is correct still. Yeah, yeah. Maybe it's not correct. Let me see here. Theta log plus mode. Oh, we left the scope already. Oops, that is not correct typing. So this one, wait a minute, the buffer isn't correct. Why is the buffer? This is what we just copied data to. Why is it still like wrong? What even happened? I'm gonna stop, I think, but since GDB is not really helping us, we're gonna have to pause, I think, because I need to get something to eat. But yeah, the dest is the new one, so why is that like screwed up? Yeah, that's annoying. Well, I think raw here is not, I need to correct raw first, because raw is now no longer pointing to where it's supposed to be pointing. But we'd break out of here, then we would say this, then we would. Yeah, so I need to fix that first. Sorry, just raw.data equals desk.data, all I'm doing. So we need to just move that pointer to where it's supposed to be, and then that's probably what the problem was. Nope. Now, if only this program actually worked. Hello, it's completely lost. Ugh. It's kind of looking like I didn't set up the... Let me look here in main. Did I set this up properly? I did. Okay, let's build this not in debug mode. So that this can be a little more helpful. We'll check that after. How is the why? What is going on here? Like, why is everything just in the wrong place? The instruction pointer is just like, nope, bye bye. Split input lines to raw. So here we're gonna get rid of this one, and we're gonna place here, here. How is this like completely just screwing up everything in the instruction point? Like, what is GDB even doing? I don't get it. I've never seen this such abysmal behavior out of GDB. Like, what on earth? I think I'm gonna have to call it for now. So, yes. Is anyone still here? So thanks everyone for watching. GDB is a giant piece of crap. As everyone who tries to program on Linux happens to know. Don't know why it like gets completely mixed up about where the stack frame is. The instruction pointer is clearly at the right location. Like, this is a real location in the binary. I don't know why it thinks it's somewhere else. Probably related to like this, why this is just getting dumped like this. But in any case, thanks for watching, and I will see you all next time. Bye.